All right, we're back. We just got done talking about this graph right here, and hopefully you told me a story with that one. Now we're going to do this one here, right? This is new reported deaths by day in the United States. So we could use this graph to tell a story too. So we're going to look at the title, new reported deaths by day in the United States. We're going to look at the x-axis, which we see is over time. This is so there can be a beginning, middle, and end in this story. And then I see that my y-axis is number of deaths, and so let me just kind of think about this, the real quick version of the story. I see a peak here between April and May, so we'll call this mid-April. There was a peak in deaths, and then there was a valley in deaths sometime around July. There was kind of a trough or a valley where there was only about 500 reported deaths per day, and then it picked up again in late July, early August at about over 1,000 new deaths per day, and then it started to go down. And in October, there was about 750 new reported deaths per day. And then now, currently in November, we're looking at almost 2,000 deaths per day if we look at the actual data. But if we look at the 7-day average, we could say a 7-day average of 1,500 new deaths per day. All right, so that's the quickie version of me just kind of looking at this 7-day average line, right? Each one of these little gray little marks is one bar graph, right? It's one bar of this giant bar graph, and then this line right here is like the 7-day average, kind of moderating the peaks and valleys of all this, right? Notice how the data goes up and down, up and down, up and down. The actual data has all these little peaks and troughs, and maybe you don't want to talk about each individual little peak and trough. But that isn't, to me, this is interesting because, right, it tells me that pandemics like this, in terms of deaths, tend to peak and trough very dramatically, and that's almost reliable. Like that's almost a predictable peak and trough going on there, peak and valley, peak and valley. So I would have to ask an epidemiologist what's going on here. Why do we see this? That's a very good question. I don't know. I have the answer. So the story I'm giving you as an example is you could say, well, in April and May of 2020, there was a spike in newly reported deaths by day in the United States. Notice how right here in my story, I use the title. I use the title of the graph, right? There was a spike in newly reported deaths in the United States, new reported deaths by day in the United States. So I'm kind of reusing the title right there in my story, which peaked in mid-April. So somewhere in mid-April, it peaked and then fell to about 500 new reported deaths per day in July as a 7-day average. Notice I used 7-day average in my story, which I saw in my graph here. And then I said, I wrote, new reported deaths also peaked again in August at over 1,000 newly reported deaths per day. And then currently in November 2020, there are about 1,500 new reported deaths per day in the United States. I probably should have added, in terms of a 7-day average in there, because that could also be interpreted wrongly if I didn't include that, right? So maybe I need to fix my story a little bit. So I do want you to notice that my story identifies this as a big peak. This is a bit of a trough, maybe another peak here, maybe another trough here, and then a new peak here, right? So we have a beginning, middle, and end going on, kind of this continuity of the story. And I also included the title in there to provide context of what I'm talking about. And so when I try to cite some figures and numbers, trying to give some rough approximations of what's going on, I'm going to have you do this one, right? So what do we have here? We have deaths, deaths by date of death in Monroe County. So this is data right here in Monroe County. So this is deaths by date of death. And what do we have on our horizontal axis? We have date of death. Okay, so we have somewhere in, let's see, March is probably right here. No, April's right here. March must be around here. So March, April, May, June, July, August, September, October, November. See how that kind of works? And then we have deaths. So we have, there's not that many, right? So this is, each little bar represents, like, that's one death. This huge bar here is 7 deaths, when then the next day it was 5 deaths. So notice in Monroe County, our data has a lot of peaks and valleys too. They're a little bit more irregular than the ones we saw before. Because we're a much smaller community, the data is not quite as smooth and complete, doesn't has a lot of this ups and down due to variability of any given circumstances of any given day. So you might, in terms of the story here, you might say we had a heck of a lot of deaths right in this thing here, which I might say between April and June. Between April and June, Monroe County experienced quite a number of deaths. I wouldn't want to count these up by hand, but I can see that it's probably around 3 or 4 per day. So you can, if you were to kind of visualize the even out of all these peaks and valleys, maybe something more like 3 or 4. So yeah, people, there were a number of people dying per day there. And then it started looking better over here, right? In fact, actually, from July on, the numbers are fairly consistent, right? Yet we don't have a peak of deaths right now in Monroe County. We got new reported cases, and of course, unfortunately, the deaths happen after peaks in new reported cases. Yeah. Of course, we're also getting better at treating the illness, so that might not be a constant. So you're going to tell a story. You're going to tell a story right here about this. So maybe you want to pause the video right now, tell your story the best you can. All right, this next one. Of course, you pause me and you unpause me. This is the last question. I thought this was a really interesting graph, which is why I included it. Unfortunately, it's a different kind of graph than any other graph you've seen before. This one is age, gender breakdown of new cases. Age, gender breakdown of new cases, where the males are this pinkish lavender color, and females are represented as this yellow color. And the horizontal axis this time is our age range. Every graph we've looked at so far had days, like months, as our horizontal axis. In this case, we have an age range as our horizontal x-axis. And our y-axis, our vertical, is number of cases. So I want you to pause this video and see if you can tell a story by just looking at this thing. All right, look at this thing and tell me what story it tells you. All right, unpaused me. Let's talk about it a little bit. I want you to tell the story. Ultimately, I want it to be you, but let's pick out some important things. Let's pick about who's being affected the most by age, gender breakdown of new cases. So most of the new cases are here and here, and maybe even a little bit there. So the new cases are mostly between ages 50 and 59. So people in their 50s. And people in their 20s and 30s. It's kind of weird how people in their 40s aren't being affected. That's good news for me. Let's see. And then there's this weird thing going on with males between 10 and 19. That's interesting, isn't it? Okay, so let's look at by gender. Males is even here. Males are there's more cases, more new cases of males here. A little bit more with males here. Females are somehow beating out males in their 30s. Females are also beating out males in their 40s. Males are winning again in their 50s and in their 60s. Just a tiny bit in their 70s, not hardly, and then a lot in their 80s. This might be a function of there's not many men that live into their 80s, right? And I don't know what that's going out. That's just not enough information there. Not enough people in their 90s to maybe make a good conclusion here. So I might say, looks like males might be affected by this a little bit more, maybe. Maybe not. Maybe I would say that between their 20s and their 50s the most, with this weird, interesting dip of people in their 40s. Maybe people in their 40s are just, I don't know. It's good. I don't know what's going on there. I don't know. And then obviously people who are between 0 and 9, not very many people being affected by it. And then not too many people being affected in their 80s and 90s. Of course, that might be a function of, people don't, people start dropping off the age representation into their 80s and 90s, right? So I'll leave it to you. Give me 3 sentences or something right here, and we'll put this maybe as some extra credit or something in there for you. This is a very useful skill to be able to look at a graph and have it be able to talk about it by telling a story. All right, so that's what we're doing here. All right, very good. I'm going to stop this video. Hope to see you in class.